All right, everybody. Today we're going to talk about right triangle trig. Remember that this, like the name implies, this has to deal with right triangles. And so we need to set up our triangle in order to see what sides we're using. And let's say that I'm going to use a side of, or an angle of 35 degrees here. And so I'm going to be focusing in from that 35 degrees. One thing that we do with the sine, cosine, and tangent is remember this nice little mnemonic device called SOHCAHTOA. And I'm purposely writing with the C, the S, and the T in a big capital letter, and the other ones are a little bit smaller because that's the sine, cosine, and tangent. The O stands for opposite. The H stands for hypotenuse. And the A stands for adjacent. And these will be ways to name our sides to see what ratio we're about to use. And so if I'm at this 35 degrees, the hypotenuse is always across from the right angle. So this was probably the easiest one. The hypotenuse is always across from the right angle. My opposite is always across from the triangle from the angle that I'm about to use. So that would be this 35 degrees. And my last side here is the adjacent side. So we're going to use this naming of sides in order to see which trig function we're about to use. And so if I have a triangle that looks a little bit like this, where I have 70 degrees, let's say, an X, and then a 5. Well, I notice that I'm using the opposite side across from my 70 degrees, and I'm using the hypotenuse. And so when I set this up, I'm going to set this up as the sine of 70 degrees equals X over 5. Multiply by 5 on both sides, I get 5 times the sine of 70, and this equals 4.70. Make sure your calculator is in degree mode. We don't want to use radian mode right now. For cosine, I have a new triangle, and let's say that I have a 20 degrees right here, I have 7, and then I have a y. So for this one, I'm going to go the cosine of 20 degrees, and this is because I have the adjacent side over here, and then I have the hypotenuse. So I have the cosine of 20 equals 7 over y. This time my variable's in the denominator though. So I need to multiply by y on both sides to get it out of that denominator. And then I'm going to divide by the cosine of 20 on both sides to get the y by itself. So I'm solving for y. So I have y equals 7 cosine divided by cosine of 20. And this will equal 7.44. And this answer should make sense, right? My hypotenuse needs to be the longest side, and so the 7.44 is larger than that 7. Finally, for tangent, let's say that I have 50 degrees. I have a z and then a 4. And so I set this up. I have the opposite side across from my 50 degrees and my adjacent side right next to it. And so I have the tangent of 50 degrees equals z over 4. I multiply by 4 on both sides, and I get 4 times the tangent of 50 equals z, and this number would be 4.77. And so that's our right triangle trig. Again, making sure that you set up your triangle and label the sides properly is what's going to help you out here. And for the inverse trig functions, we're finding an angle. And so this time, if I'm given a triangle, and it needs to be a right triangle, I'm searching for this variable, and this variable right here is called theta. Oftentimes we use this essentially just like we do x for sides, but we use theta for angles. So we'll be searching for theta here. And let's say that I have 20 and then a 30. So notice that the 20 is my opposite side, and the 30 is my hypotenuse. And so here I'm going to do, it truly sets up as the sine of theta equals 20 over 30. But then in order to actually solve for theta, right, we don't have a function that undoes the sine function. Excuse me. And so we're going to take the inverse. It's a new function that we're going to be able to use. So I'm taking the inverse, and essentially it's like sine to the -1. And then I'm going to input my ratio here, and this will equal theta. So if I go, and at this point, of course, I'm using a calculator. So I'm going inverse sine of 20 over 30. And I'm getting 41 0.81 degrees, right? Because that's the unit we're using here. So that's the inverse sine. For the inverse cosine, we have a triangle. I'm going to solve for theta over here, and I have 22 and then 50. And so I set this up very similarly. I go cosine of theta equals 22 over the 50. And so I do the inverse cosine of 22 over 50 equals theta. And let's see what this equals. Inverse cosine of 22 over 50. I got 63.9. So I'm rounding to the nearest hundredth, but I have 0.896. So I have 63.9 degrees. And finally, for tangent, I'm solving for theta. I have 14 and I have a 5. And so this will be the tangent of theta equals 5 over 14. And I take the inverse tangent of 5 over 14. And this will be theta. So I'm typing this into my calculator. Inverse tangent of 5 divided by 14. And I got 19.65 degrees. So that's our right triangle trig. The big thing to remember here is this SOHCAHTOA to identify our sides properly and go from there. Hope this helps. Thanks.